Okay, welcome to question 5a from the 2010 scholarship paper. So we're finally on to the last question in this video series. This first part A is about identifying 5 elements designated as B, W, X, Y, and Z, and you're given the following properties. Note that these letters bear no relationship to the symbols of the elements. So what I'm going to do is I'm going to first of all read through all the evidence here. And then what I'm going to do is I'll expect you to have printed out this question and have this evidence beside you to follow the rest of this video, because I'm going to just show a screenshot of the periodic table, which is essential to identify each of these elements. And then I'll also use a blank page to just show how I arrive at the different identities. So the information we're given is as follows. Elements B and Z have the same number of valence electrons. Now, if you have the same number of valence electrons, that means you're in the same group. That tells us those two elements are in the same group. B and Z are in the same group. So same number of valence electrons, same group. The second bullet point, the molar mass of the elemental form of element B is 2 grams per mole. Now, if you look at your periodic table, you should find that there is only one element which can have a molar mass close to 2 grams per mole, and that's hydrogen. And what they mean in its elemental form is, well, hydrogen in its elemental form or at room temperature and pressure exists as H2 gas, and that will give you a molar mass of 2 times 1 gram per mole, which is 2 grams per mole. So that element V is hydrogen. So they have to give you one to start with. So V is equal to hydrogen. Okay, element W is the most reactive member of its group, which contains only nonmetals. So nonmetals are going to be on the right-hand side of the periodic table. We know that much. What else can we say from that? Well, that's all for now, really. We need to read on and get a bit more information. The valence electrons of elements X, Y, and Z are in the same shell, which means they're in the same row of the periodic table. Element Y has a lower first ionization energy than element X. Now, this is the one trick that might trip you up. It caught me out. Lower first ionization energy typically means that you're further to the right-hand side of the periodic table, and that usually means you're more electronegative. But just keep an eye on that one, because, as I said, there's a trick or a sting in the tail there, and it caught me out. The next bullet point, elements Z and Y react to form the compound Z2Y, which dissolves in water to give a basic solution that conducts electricity. Basic solutions arise from group 1 or group 2 metals, because their traditional names were alkaline metals or alkaline earth metals. So you know that element Z must be either from group 1 or from group 2. But of course, we've already identified that elements B and Z have the same number of valence electrons, so should be from the same group. So if hydrogen is from group 1, then this means that Z must also be from group 1. So we can eliminate the possibility of it being from group 2. Next bullet point, element B reacts with element X to form Xb3, which is a poisonous gas. So we can't do much with that just yet. The ions of elements W and Z have the same total number of electrons. So what we can talk about here is, well, the same total number of electrons is going to be the same atomic numbers. Now this is of the ions, so the same atomic numbers, the ions match up. Element B reacts with element W to form VW, a gas at 25 degrees Celsius, and element B reacts with element Z to form ZV, which is an ionic solid. So also, if the metal part is Z, if Z is a metal from group 1, V must be a non-metal, and similarly, W must be a non-metal as well. And they've told us that already. W is the most reactive member of its group, which only contains non-metals. So we've quite a bit of information gathered just from looking at that. The next thing I want to do, as I say, is I want to go to the periodic table. So I'm just going to open the periodic table and start writing some things on it while still having these hints on a piece of paper in front of me. So you do that too as well. Get your piece of paper with the exam question on it. Okay, so we now have a periodic table open, and this is going to be very important to help us figure out the identity of the rest of these elements. We've already said hydrogen was equal to V, so we know hydrogen is element V there. The next thing we figured out is the molar mass. So V and Z have the same number of valence electrons. The molar mass of the elemental form of V is 2 grams per mole, so we said that was hydrogen. Element W is the most reactive member of its group, which contains only nonmetals. Now, the most reactive nonmetal is going to be fluorine, because it is the most electronegative. So it's the most electronegative, the best at grabbing electrons essentially from the metals. So therefore, W is fluorine, the most electronegative or most reactive member of the nonmetals. The next bullet point down, the valence electrons of elements X, Y, and Z are in the same shell. We're going to leave that for a minute. Element Y has a lower first ionization energy than element X. Again, we're going to leave that just for now. Elements Z and Y react to form the compound Z2Y, which dissolves in water to give a basic solution that conducts electricity. I'm also going to skip that. I'm going to just go to the third last bullet point. The ions of elements W and Z have the same total number of electrons, because we've already said that element Z has the same number of valence electrons. That's the first bullet point that we're given as hydrogen. So we know that element Z lives in group 1 somewhere. It's an alkaline metal. It also reacts with a non-metal Y there to give you Z2Y. So as a non-metal, or as a metal rather, it must form ions with +1 charge there. So anyway, Z lives in group 1, and the ion of the element that is Z, the ion that it forms has the same total number of electrons as W. So W has 9 electrons, but the ion that it will form will have 10 electrons when it ionizes. It gains its 1 electron. And then if the only element here which can lose 1 electron to have an atomic number of 10 is going to be sodium. When sodium forms its Na plus ions. So Z is equal to sodium. Z is equal to sodium. So we've now identified of our 5, we've V, W, X, Y, and Z. We've identified V, that was hydrogen. We've identified W, which was fluorine. We haven't identified X, Y. We've identified Z, which was sodium. So now take a look at the information for X and Y. Well, if we take a look at, so by the way, Z2Y, well, this is going to be Na2 and something, so we still don't know what Y is. So let's read on. So the valence electrons of elements X, Y, and Z are in the same shell. Now, Z is sodium, make sure you know that, not sodium ions. So if Z is sodium, and that's in row number 3, because hydrogen is row number 1, row number 3 for sodium, and these elements here, Y and X, are nonmetals, well then we can say that they must live somewhere within this section of the periodic table, somewhere within the P block of the third shell. So let's take a little bit more information. So X and Y live in here somewhere. Okay, and that comes from that bullet point there, that the valence electrons of elements X, Y, and Z, where Z is sodium, are all in the same shell. Element Y has a lower first ionization energy than element X. So this made me think that element Y should be further over the periodic table. Element X should be further over the periodic table than Y, because the trend in electronegativity should be that it increases as you go from left to right. So electronegativity, the general trend is it increases from left to right on the periodic table. So if element Y has a lower ionization energy than X, then I thought that Y should naturally come before X. but you need to be aware of slight anomalies in that trend. So be aware of the anomalies in that trend, because that's not actually the case in this answer. We'll read on. Element Z and Y react to form the compound Z2Y, which dissolves in water to give a basic solution that conducts electricity. Element B reacts with element X to form Xv3, a poisonous gas. And the ions of elements W and Z have the same total number of electrons. We've covered that. Element V reacts with element W to form VW, a gas at 25 degrees Celsius. Now, V and W, well, we know V is hydrogen, and we know W is fluorine. So this VW compound is equal to hydrogen fluoride gas. So we've identified that. Element V reacts with element Z to form ZV, an ionic solid. So Z is sodium and V is hydrogen. So that's sodium hydride, which is a solid. So we've identified that. So we still just need to identify our X and Y elements. So the way I identified element Y was that when you're told that Z plus Y gives you a compound which is formed as Z2Y, if Z is sodium, so two sodiums, we need Y with a ionic charge of -2, and that means that it must come from the same group as oxygen, which means that Y is sulfur. So that would be Na2S. So sodium sulfide is that solid right there, which dissolves in water to give a basic or alkaline solution that conducts electricity. So Y is equal to sulfur. So we now have Y is sulfur. So the last one here now is X, and this is where I got tripped up. I identified all of the others successfully. But the mistake I made here was on this point of information, and I'm just going to go back to the exam. We don't have it there, so we'll just read it out. This point here, that element Y has a lower first ionization energy than element X. So I thought that element X should then be somewhere here. So basically it should be either chlorine or argon. Now we know argon is inert and pretty much doesn't react with anything, but that's not completely, can't be completely ruled out, as some noble gases do react. But what's needed to consider was the actual values of electronegativities for phosphorus and sulfur, because phosphorus is electronegativity is slightly greater than the electronegativity for sulfur. So that's electronegativity for sulfur, that's for phosphorus. We'll just quickly take a look at that on a web page here, for example, that I have opened up. So you can see there that that's phosphorus and that's sulfur. So it's actually slightly greater. So this is an example of an anomaly in the trend of ionization energies or electronegativity across the periodic table. And just to explain why that is, so if we go back to where we're writing here, the reason that the ionization energy is slightly higher for phosphorus, and we just get a bit of space down here to write this. Phosphorus, the electron configuration for phosphorus would be everything as far as neon, and then 3s2, 3p, 3p3. I didn't write that very well. Let's just do this correctly. So 3p3, which is a half-filled p orbital, which is more stable, slightly more stable than the situation for sulfur, which is everything as far as neon, 3s2, 3p4. So as a result of this slightly more stable electron configuration for phosphorus, its electronegativity is slightly higher than that of sulfur, and therefore the element X is actually phosphorus. And phosphorus will produce a poisonous gas with hydrogen, pH3, which is that poisonous gas they talk about there, Xv3. So pH3, Xv3 is phosphorus, phosphorus trihydride, I guess you'd call that. I think I have that open. Okay, so I just looked up pH3 to get the correct name for it. pH3 is called phosphine. Phosphine is the compound, the chemical formula pH3. It is a colorless, flammable, toxic gas. Pure phosphine is odorless, but technical grade samples have a highly unpleasant odor. So that's phosphine, pH 3. Okay, so that is everything identified for question 5. So element V was hydrogen, W was fluorine, X was phosphorus, not X. X was phosphorus, Y was sulfur, and Z was sodium. And that was question 5, part A.